All right, so new question here. You can't see the whole question here, but the question is asking us to find the potential difference across the 5 ohm resistor. All right, so that's what our final goal is going to be. Let's see what we can do. Now, the first thing that I'm going to do, I'm looking at this, right? I see that the current comes out of the battery, then it goes up. Some of it's going to go through here. The rest of it is going to go up through there and split and go through those two guys, come back together through the 4, come back down. Then it should rejoin what's happening here and then come back to the 12. All right, so that having been the case, the first thing I'm going to do is I'm going to go ahead and I'm going to combine these two guys right here, because eventually those are going to need to combine with the 4 over here. But for now, we're just going to try to combine first that 6 and that 12. Now, the way that works, they are in parallel. So 1 over the equivalent or the total resistance in parallel is going to be equal to 1 over 6 plus 1 over 12. Now, the 1 over 6 is the same thing as 2 over 12. So I put those together, and I end up getting 3 over 12. Now, 3 over 12 is equal to 1 over RP. So I reciprocate that, and I get 12 over 3, which is 4 ohms. Now, that should make sense, because remember, anytime we have resistors in parallel, the total resistance should be less than either one of the ones that were before. I'm also going to, at the same time, I'm going to go ahead and put the 3 and the 5 together here, because my goal right now is to find the total resistance of the circuit. And if I find the total resistance of the circuit, then I should be able to find the current. And from the current, I should be able to find the potential difference eventually going across that 5 ohm resistor. So I'm going to go ahead and put the 3 and 5 together, which is just going to be 8 ohms there. So now I'm just going to redraw the circuit, right? So it's a little simpler. So it goes up here. It goes through. Now if I combine the 3 and the 5, then that now makes this an 8 ohm resistor, and that's 12 volts. Okay, and then it goes up. I've got, now I combine the 6 and the 12. That's this 4 ohm resistor. And then there's another 4 ohm resistor there, right? And then the 12 volts. So now I'm going to go ahead and put the two 4 ohms at the top together. So those guys are going to be 8 ohms. So this is because those two are in series with each other. So that'll be 8 ohms at the top. So again, let me just kind of redraw it. Sometimes it helps. If you can do it without redrawing it, then be my guest. Don't worry about redrawing it. But I find sometimes it's helpful to just keep putting them together until I come down to one single resistor. So now I've come down to these two. They are in parallel, and so I'm going to do 1 over 8 plus 1 over 8. That should then be equal to the 1 over the resistors in parallel. This will give me the final thing, which should then be 2 over 8, which means the resistance in parallel, again, should be less than each one of those individually. So this is the total of the whole system, is 4 ohms. All right. Now at this point, I'm feeling pretty good about that. And so I'm going to say, okay, so the current of the whole circuit, the total current, is equal to delta V over R. We know that the delta V is 12. That's the potential difference of the whole circuit. And then I'm going to divide it by the resistance of 4 ohms, which means that the total current there is going to be equal to 3 amperes. All right, so that's the total current. Now, the question was asking for the potential difference across the 5. So now I need to figure out how much of the current is going through that one. Now, it's kind of nice that I've actually already done some of this work, because in this drawing right here, you'll notice that when the current comes out of the battery, that it's going to split, and some through this path, some through the other one. and they each ended up with 8 ohms each. Now, if they have the same resistance, then the current should split evenly between them. So if I have a total of 3 amps, then I should get 1.5 amps through this path and 1.5 amps through the other path. All right, now that's helpful because in this drawing, if I go back to the main one now, that those are in series, which means I'm going to get 1.5 amps going through all of those, right? I'm going to get 1.5 amps going through the 3 ohm resistor, and then I'm going to have 1.5 amps going through the 5 ohm resistor. And so the question is about the 5 ohm resistor there, and so I'm going to go current through the 5 ohm resistor is equal to the potential difference across the 5 ohm resistor divided by its resistance, which of course is 5 ohms. Now the current going through that we did say was 1.5, so I'm going to go ahead and replace that with 1.5. I multiply by 5 and I get 7.5 volts is equal to the potential difference across the 5 ohm resistor. And that's all I was looking for, 7.5 volts. So congratulations, we're able to figure out that the potential difference across the 5 ohm resistor is 7.5 volts. Okay, you could do it for any of the other resistors at this point. You know that you're going to have 1.5 amps going through the 3 ohm resistor. You're going to have 1.5 going through the 4 ohm resistor, right? Because you got 1.5 amps going through the top. The only thing that's going to be different is if you need to do the 6 or the 12 here, you're going to need to figure out how much current goes through each of those paths. All right. So anyway, that's what we were looking for. Nice job.